Howdy. Welcome to exercise application video number 22, I believe. So today I did an arm day, just a general kind of upper body day. And what I want to talk about is actually something I referenced a couple videos back, but for whatever reason I got my schedule mixed up in my head. So I actually want to talk about the oxygen hemoglobin dissociation curve a little bit further today. And I want to talk about how that specifically relates to acid and carbonic acid and the dissociation of carbonic acid. So I mentioned the other day that once we use our transporters, things like the MCE, to get our acid, that being things like our lactate or hydrogen, into the bloodstream, and our carbon dioxide as well, which we're creating as we convert pyruvate to acetyl-CoA. We're getting that in, as well as the ETC, we're getting that in the bloodstream. And so then what we see is that water and carbon dioxide combined together form carbonic acid. And so then we're in the red blood cell as this happens, they dissociate into a hydrogen ion and bicarbonate. And that hydrogen ion actually goes into the red blood cell and it denatures the hemoglobin, right? So our hemoglobin is a protein molecule, and proteins are very sensitive to certain conditions, one of which being pH and acidity. So as we add hydrogen ions, we are lowering the pH and increasing the acidity. And that protein, that hemoglobin, says, hey, I have to operate at a very specific state of functions, so it begins to just fall apart in that specific acidity. So as we denature that hemoglobin, so as we're increasing to exercise, because right, as we increasingly exercise, we're creating more and more acid. Why? I'm going through my ATP quicker. Within the goldfish model, I'm hydrolyzing ATP faster. I'm using more glucose, thus producing more lactate, more NADH, especially in high intensity exercise, which today was high intensity exercise. So my body was producing more and more acid that I had to buffer. You're producing more CO2, again, with higher intensity exercise. You're seeing more carb usage, so more acidity. That's one of the reasons why using fat is a little more sustainable, which we will soon get into. But as you're exercising, so as I was doing my chest press for sets of 8, I was using lots of carbs, producing more acid, and so my hemoglobin was dissociating faster than when I'm at rest because I have lots of acidity, and those hydrogen ions were denaturing my hemoglobin, which that's actually how we drive the hemoglobin dissociation curve, and that's why we see a shift in that curve to the left as we exercise, because we are more rapidly dissociating. Those oxygen molecules are more quickly getting into our muscle. So when we say they're dissociating, they're going from the bloodstream, the capillaries, into the muscle, because our muscle has a higher need for that oxygen. It has a higher need for that oxygen, but on the acidity side of things, we're denaturing that hemoglobin at a faster rate. So I just wanted to get a little more into that. I know that's something we talked about earlier with respiration. Of course, there's the aspect of we're transporting oxygen, which we use as a final electron acceptor, and there is the kind of respiratory cardiovascular drive behind that, but there also is an acidic and a buffering drive behind that. So yeah,